Thank you. Moving on. Oh, okay. So this is what I was just talking about. Retrieving the default error message. Well, we're going to be able to get method calls from the object, like we just saw the object E. So let's take a look at 11.3 and 11.4. And, again, purpose of these code listings is to give you an idea of what's going on before we cover it in class. How a file not found exception can be handled. I come in and I have my try block right there. File, new file, input file, all of that. We come in and we catch it. And this time I'm going to use one of the methods from the file not found exception class. So my object E, which is my parameter coming in, calls get message. Now, we don't do a ton of work with this, so I'm not going to say, hey, everybody go to file not found exception Java and look up all the methods that are in there. So let's see, what would the message be? So the default method is, oh boy, if I type in a bad file name, it says badfile.txt, the system cannot find the specified file. So it's something, but you notice after this happens, my program doesn't crash. My program comes out of the catch block and it does, oh, done. And it finishes up. So it didn't crash, even though so we're going to be able to make catch blocks to do all kinds of things. Not only that, but since it doesn't crash, I may possibly inside of my catch block say, hey man, do it again and push us back up to the try block so that I stay in it and ask for a new file name. Something along those lines. Cool. Here's another one. Instead of continuing to work with that file not found, here is another class, number format exception, right? I'm bringing in an object E, and there is a get message method inside of number format exception. It's almost like I am made to do this, but I'm not, because you didn't see any kind of, what did we learn last week? The one where it said, hey, you have to follow these rules. Starts with an I.
Inheritance?
Yeah, we talked about inheritance in the last class and saying, hey, everybody has to have a get message method. And it may be we just don't know it or need to get into it. So if I run this program, and I'm sure you typed it up, it compiled, it ran, you were happy, and you moved on. Well, did you try something that wouldn't work? So I have this string, and I mean, it would work. And I have a string and I try to parse it. Oh no, it crashes. It gives me a message down here at the bottom, conversion error for input string ABCDE. All right, not too bad. It gave me that message that it couldn't convert it. Well, what happens if you would actually try to put 63 in here? Does it actually work? And what's the output if you did put 63 in there? Doesn't look like it does anything, does it? That answer would be no. So if it actually does work, nothing happens. But we're just taking a look at another class that is a subclass of number format exception. All right, moving right along. Not hearing any questions. 11.5, 11.6. What if I wanted to handle multiple ones? Well, I can. I have a try block. My try block is this huge one up here in 11.5. Okay, it's a huge one. But you notice I have a catch in case up here throws a file not found exception. I have a catch up here in case there is an input mismatch exception, and I can have multiple ones. Good to know. Good to know. I really do need to understand what each of these classes are so I know what to catch and work with them. So typing these in, the file name doesn't exist. For this one, you know, I was trying to get a number and it didn't work. So let's see where that was. I was trying to input a number, and if it didn't work up here, if I brought something in and it was, yeah, then I would have a problem. And hey, no, you know, that's not such a bad thing, because I could have somebody typing in a whole bunch of doubles for me, and all of a sudden one of the lines is A, and they keep typing in numbers, and normally my program would crash because it couldn't get the A, but now I can catch it and not have the program crash, and even go one step farther, like code listing 11.6 was, in which I'm going to keep the program going. And if I flip the page, this is, you know, I have a while. Let's see what we have going on in this program. I have a while input file is null, I get the input file. I'm going to take a look at while it has another number. I'm going to come in and work with it. But if there is a mismatch, it's going to come down to the catch block and get the next number and send me back up into here so that I can keep processing. So this is kind of neat, that if somebody did enter A, that was me not stuttering, that my program could continue with the use of that while loop. Cool. I like it. I love it. I want some more. Oh, sorry. Same program. Nice and big one for you to type in. 11.6. Had another try and catch set up. And this time we noticed that it's tucked away down here at the bottom. It's out of my method. Questions? Okay. Moving down through, and we had this other chart. This other UML chart with just the class names. But what if I wanted to come down and just, right now, I'm just going to take a look at inheritance down this one chain. Okay, so I have object throwable exception, runtime error, illegal argument exception, or runtime exception, and number format exception. Just going down through that one chain. Okay, and again, this is bringing that idea of inheritance in that we just talked about. Now, when I'm catching these, okay, I have this going on, and I say number format exception, and I have, next page, I'm sorry, excuse me. I have this layout, right here it is. I have a try, and I have a catch illegal argument exception, and I have a catch number format exception. Now, the order of these does, in fact, matter, because we're never going to get to number format exception. So let's see. Number format exception is here. Illegal argument is here. So if I want to catch the more specific first, I have to list them first. If I want to catch the more specific first, I have to list it first. So over on this page, this is the more specific my number format. So a legal argument will catch as a parent and all of its children. So if I want this to be done first, I have to move it up. And as you see here, it's actually moved up that we do the lower classes first and work our way back. The reason is these are more specific messages that would appear. These are a little more general. And the higher up, the more general and the more general they would be.
So that just won't compile.
Now it'll work, but if a number format, so this is a legal argument. So when it gets ready to find a message, so an exception is thrown and it's going to come down through and it's going to say, oh, nope, that fits under a legal argument. Everything goes there. But because I put that first. But if I would have listed number format first, it would catch any number format errors first, then move down to the next catch block, which was the illegal argument. So a legal argument is a parent. A legal argument is a parent. It's a parent to this. So this parent catches children. This being a child, it's never going to happen because this guy catches it. Down here, I list the child first. So if it's specific to number format exception, it'll hit this. If not, then it'll keep looking.
Okay, so it won't crash. So like if you
Right.
made that mistake, then it would be hard to, it might be one of the mistakes that'd be hard to debug.
Well, you would never see this is not a number. Everything would come out as bad number format.
Yeah.
Yeah,
So
exactly.
quick question, there'd never be a reason to write code like that top block then, like there's no point in even writing that. The catch number format beneath.
That one, that's right.
Yeah.
Yep.
Okay.
Yep. So you always want to do children first and work your way up.
Oh, is that the same for when we're using the syntax where we have like multiple catches in the same big line?
Yes. Yes. You saw an example of that. Good. Yep. All right. Down here at the bottom of the page, we talk about something called the finally clause. And the finally clause is one that after a catch block, this block will get done no matter what. Okay. And there's an example here, and it's a perfect example of making sure that something happens. And in this case, we want to make sure that the file gets closed. So if it does the try and everything works great, you know, we want to make sure that it's closed. If it crashes and we have an error message, we want to make sure it gets closed. Now, the other thing that's kind of interesting in here is I have a try block and a catch and a finally inside of a bigger try block that has its own catch. So we would actually come back to a word we're familiar with. It's a nested try block.
Professor.
Yeah.
So is that the only time we use a finally block is if we want something to compile inside of a try block that's nested, because otherwise we just put it outside of the entire try catch block, right?
Okay, so normally if I get an error message, it's going to come here and then dribble its way out. You know, I had this error message and the file may never get closed. And you could get, and I've done this, and I can tell you, I was using an Apple IIe software that I had written, and I couldn't figure out what the problem was because I didn't close the file and I had an integrity error. So this will make sure that it hits those lines of code. And again, in my notes, I put it's optional. You know, you don't have to have it. It's nice to have it if you want, but these will always be executed. And the big example is to close that file. Okay, stack trace. This is kind of neat. When we first started programming, we were getting error messages that we had no idea what the problem was. Part of the error message is, well, we were looking at this going, okay. And we may have caught string index out of bounds and worked with that. But as you can see here, I can start to look at some of these, and my stack trace says, well, main, I went to something called my method, which was part of the program. Over here, I had a method called my method, and inside, come on, inside my method, I actually called something produce error. And as you can see inside my method, I called something produce error. So it's starting to, what we say, unwind this stack to get me to the point where my error actually occurred. And of course, inside of produce error, which is what I called, I have a string, and I try to do a char at 3, 0, 1, 2. Yeah, there's no 3. So I have a string index out of bounds. So some of this is starting to make a little more sense. In main, I call method my method, which calls a method produce error, which says I have a char at problem. And when I look up here, I see my char at. So this is actually really something that, okay, we didn't get before, but throwing it out to you right now. And finally, the last thing in section 11.1 before I yell at the dog is someone was asking about catches with multiple names. And here's an example of what that was. Questions? The dog has a question. All right, let me switch over my notes. Section 11.2, going to keep rolling with that. And pause for 1 second. Section 11.2. I do apologize. We're going to talk about something that is a code listing, and eventually you're going to have to type it in a little bit. But throwing an exception. Now, we used what's provided up to this point. We had classes that took care of when a certain type of error occurs. But we're going to now take a look at, there it is, creating your own exception class and how we can work with that. So let's see what we have going on. Throw new exception. So it's not automatically thrown. We're going to throw it. Contains a custom message. We can pass as a parameter, a string. The throw statement, as I said a little while ago, does in fact cause that exception object to be created and then go to the class. And finally, that message is in fact optional. So we're going to take a look at a code listing. Did you type in 11.9, or is that where it ended? I think you did do 11.9. Is that correct?
No.
No.
6.
Okay. So 11.9, guess what you have to do for the next class? Well, we're going to talk about it a little bit right now. I have a program, the dice class. It's not Andrew Dice Clay, it's the dice class, simulates a 6-sided dice. All right. And yeah, we did the dice class some time ago, but so this is a version of the dice class, and we're gonna make sure that everything works in this dice class. We're gonna set it up with the minimum number of sides equals 4. So we have that written down. We have 2 inside of this class. We have 2 and only 2 variables, sides and value. We come in, it's the dice class. So we have a dice constructor with the number of sides. And if I instantiate an object of the dice class, and I come in and the sides is a number smaller than 4, I want it to. So what do? I'm going to throw a new illegal argument exception. That's something I'm making up, a new illegal argument exception. And I'm going to pass a message in that says the die must have at least 4 sides in this case. Okay, let's see when I come out of here, and here we go. If the number of sides is not going to be thrown because it's an error, then sides equals number of sides, and we call a method roll. Roll comes down here, gets a random value, and so forth and so forth. All right, so I have a class that I just created. I have something I haven't seen really before, a constructor that calls a method to get this program up and running. So let's see what the demo looks like. 11:10. Public static void, number size, die equals new, and I'm sending in a 1. And the 1's going to go in, and it's going to say, uh-oh, we have a problem. An illegal argument exception. We passed it in. Okay, remember, this is, I think I said this is one we're going to write. Not yet. That's coming up next. This is one that's written. We send our own message in, and we get all of this to display. The die must have at least 4 sides. My apologies. I forgot illegal argument exception does exist. Questions on 11.9, 11.10?
So I guess that when we write our own exception, it's not a checked exception where it forces us to
Correct,
do it in a try catch. Okay.
correct. All right, so now we're going to write our own. And then you're going to add to it in a little bit here. But we're going to write our own. We have 17 people here now, almost the whole class. That's going to bring our attendance up from a 90.4. Tan, are you here? I'll do attendance in a little bit. Okay, so beautiful. I love the UML charts. I hope you do. Some of you coming out of 162, you know the importance of pre-planning before you start typing, and this is a huge way to do it. But there's something called bank account, and bank account we did back in chapter 6, believe it or not. We had bank account, and I can look at this and say, okay, I understand everything's going on. I have a balance. It's private. It's a double. I have a default constructor. I have a constructor that brings in a double. And I have a constructor that brings in a string. That string's going to probably get converted right away to a double. So I have 3 constructors. We say they are overloaded because they have different signatures. Okay, I had a deposit, bring in a double and add it to my balance, or a string and add it to my balance. I had a withdrawal. Okay, I could either be returning a double or a string. I could set the balance right away, or I can get the balance. So not many things going on. But for this class, we now want to get ready and take care of, well, what happens if a negative starting balance is passed in? We can't have that. We need an exception to occur. And you see where these are specific to our program, but they're like the generic ones that we've looked at up to this point. A negative number is passed to the deposit. A negative number is passed to withdrawal. The amount passed to the withdrawal method exceeds the account's balance. So we have a whole bunch of classes that we're going to take a look at here in a second. All right, I'm creating my own. The very first one is called negative starting balance. So if an exception occurs, I'm going to throw an error and its type is going to be negative starting balance. And you notice it extends exception. Kind of makes sense. We have to do that. All right. So if there's a negative starting balance, it's going to come into this class. I have nothing really but constructors for negative starting balance. Call either the super or one that I wrote with the amount in it that says can't have that. Here's an example. I'm going to work on getting this created and I'm going to throw negative starting a balance. This is throws, just like it was the IO exception. Here's a throw. Okay. Again, I love my documentation. This program demonstrates how the bank account class constructor throws a custom exception. So if I call this constructor and I come in and I say, hey, I want to create a new object called account of type bank account. If I throw in a negative 100, boom. System.out.println.get message. And again, this is the negative start balance. This is going to call what we've seen before, E as an object name. Here's my error message that was created. Error negative starting balance, negative $100. Still with me? I hope so. So I have, let's go through this again. I have a negative starting balance passed to the constructor. I have a negative starting balance being passed. So I come into my program, okay? And inside of here, I say, hey, I want to instantiate an object called account. And I have a message. And when I go to bank accounts, when I go to bank accounts, the following code shows one of the bank accounts constructors rewritten to throw a negative starting balance. Okay, so here's that bank account constructor, throws negative starting balance. If the starting balance is less than 0, I want to throw that, otherwise it just becomes balance and everything's good. If I throw it, where does it land? In this catch block. So now we're seeing a little more involved because we are jumping around. We're jumping around. So this is my demo program. This is me with that first exception. The very first exception was the negative starting balance. This is a class by itself. It extends exception. Okay. Inside of here, inside of this class, you see I have a negative starting balance and negative starting balance. So this is what's going on. If I instantiate an object and there's a problem, it's going to hit one of these two. Okay. Public account, double, start balance. This is inside of banking account. So what we just looked at up above was a class we created. Here is bank account, which I don't know if I have it on D2L or if you have to go back to chapter 6 and find it. But here's the code you would put inside of bank account to replace its constructor, the one where it has the double as a parameter. So before it would have just been balance equals start balance. But now we're going to change the code in here so that if there is a problem, we have the throws negative starting balance. And then here we're actually throwing it. So here it's getting it ready to throw and telling me where it's going to go. Here it's actually throwing it. When it's thrown, it's caught back in this demo. So what I'm going to have you do now is we just did a negative starting balance. So now I want you to come up with 3 more classes. This one, dealing with withdrawals, negative deposit, negative withdrawal, and finally, if it exceeds the bank account when I try to withdraw an amount. So 3 more classes, like code listing 1111, that I will then go back and manipulate balance like I did the constructor here, so that if it happens in my demo, I can have more try and catch blocks to catch those. Well, now that sounds like a whole heck of a lot of hoochie mama stuff going on there. What do you have? You have 25 minutes. Probably didn't need to have that crash, but I'm gonna put you in breakout rooms. Was anyone able to find bank account yet?
I believe you have it on D2L.
Did I put it on? Well, that's good. That's good. So grab that, start to manipulate it with what you see in 1110 and 1111. And go from there. Hopefully somebody will upload it. Hopefully your questions are answered in your groups. And I'll be around.